Okay, so we're going to go ahead and get started on the graphing of rational functions. Okay, now a rational function again is one in which we have x is in the denominator. We have it earlier on, if you'll remember, we did quadratics, we did cubics, we did quartics, and all of those, the x's were in the numerator. And so again, this is where we have x's in the denominator. So your very basic function for a rational looks like 1 over x. Now, if you'll remember when we've talked about rational functions in the past, we have talked about what we call the excluded values. In other words, what can x not be? Because if we put an x there, we would have a 0 in the denominator. So in this case, we know that x cannot be 0. And so when we do rational functions, the things that makes them different than a lot of the others that we do is we have, again, what's called the asymptote, which is, again, it's a line that, kind of like an imaginary line on your graph. It's not an actual line that you graph, but it's a line that your graph will get closer and closer to, but never cross. So it's kind of like it's just going to skim right over the top of that line, but never actually hit it. Okay? And we have 3 types of asymptotes. We have one that we call the vertical asymptote. So since it's a vertical line, it will always be x equals some number. Okay? We have your horizontal asymptote, which is again a horizontal line. So it will be y equals some number. Okay? And then you have that we don't see as often, but we have an oblique asymptote. In other words, we could have one with a positive or a negative slope to it. And again, that one's going to be y equals mx plus b. Now, for the most part, to get your vertical asymptote, guys, then all you ask yourself is, what is the excluded values? Okay? What are the excluded values? What can your x not be? For your horizontal asymptote, sometimes that's a little bit easier, but typically it is y equals 0. So if we haven't shifted our graph up or down, it's going to be y equals 0. Now, how do I know if my graph has been shifted up or down? Well, if you'll remember, when we start doing translation, so this again is the, whoops, excuse me, where did that have to go? Since this is the basic function, the translated equation, okay, will be f of x equals, and it would be 1 over x minus h plus k. So if, in fact, I am translating this graph, the horizontal, then there will need to be a value out here, a plus value. So it would be your graph plus some number. That's going to move it up or down. Okay? How do I know if there's an oblique asymptote? Well, if there's an oblique asymptote, it should kind of remind you of our long division problems. It is where you are going to have a number on top that is bigger than the bottom number. So m is going to be greater than an n. And it would be an example, and this is a very simplistic example, would be like an x squared over an x value. Now, of course, that could be x3 over x2. You could have an x3 over x. It doesn't matter as long as the top number is bigger than the bottom number. You're going to get that oblique asymptote. Okay? So, again, your vertical asymptote is your excluded values. Okay? Your horizontal asymptote is the translated graph. And your oblique asymptote is where your exponent on the top is greater than your exponent in the denominator. Now, that is 1 over x, and that graph, the basic graph, guys, again, will always set in this quadrant, okay? Now, I've showed you on multiple occasions that one of the things that is true, if it is this basic graph, okay, then it will hit the 0.11 and the 0.1, or -1, -1. And then, of course, after that, then it is half of that, so forth, on down. And so it's the same would be here, half, 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 and keep going. Now, if you, or not half, but points like that, sorry. The other one that we're going to look at then is if you have f of x equal to 1 over x squared, okay? Now, the difference being on these two is that when it is 1 over x squared, it doesn't matter what x value I put in. I'm squaring it. So if I have a negative, and I should have put my asymptote lines in here, okay? Sorry about that. So again, I'm going to have my same asymptotes, okay? But what's going to happen is if I put in a positive 1, I get a positive value. If I put in a -1, -1 squared is also a positive value. So the difference in our graphs are going to be that instead of it being in opposite quadrants, they're both going to be in the top or in the bottom. Okay, so now it's going to look like this. Okay, and again, that has to do with the fact that whether I take a negative and square it, or if I take a positive and square it, I'm going to get a positive in both cases. So it's going to be up. Now, I didn't mention what happens if there is a negative value. Okay, so if I have, keep hitting that, if it has a negative value out in front of it, then all it does is it switches it to the other two quadrants. If it's a negative value out in front of here, it's just going to flip it down to the bottom. Okay? Now, a lot of times, well, let me go ahead and do this one. So the other is what happens if there is a number on top that is not 1. So maybe it's y equals 2 over x, or y equals 3 over x, or y equals 4 over x. Well, what happens to your graph is, one, it does not change my asymptotes. So my asymptotes are still going to be x equals 0 and y equals 0. And we do need to label these: vertical asymptote, horizontal asymptote. Okay? So we do label which one is which. So what's going to change here, guys, is that when I put that 1 in, now I have 2 over 1, which is 2. Oops, sorry, that is not 2. 1, 2. Okay? If I put a 2 in, now I'm at 1. See? So now my graph, I've got a, whoops, again, you shouldn't cross that, but your graph's going to come here. So again, -1, -2, and at 2, it's a -1. So what you're going to see happen is this is going to be moved out further. Okay? If I have a 3, then when I put in a 1, it would be 3 over 1 is 3. 3 over 2 would be 1.5. 3 over 3 would be 1. And do you see how it's going to take that graph and it's going to move it out? So again, in here, it's going to move it out. And if I did 4, okay, if I did 4 over, then I am going to, when I put it over 1, I'm going to have 1, 4. When I put it over 2, I have 2, 2. When I put it over 3, I have 4, or I have 1 1/3. Okay, so again, now it's going to come here. So by putting that number on top, it's just moving the graph out. Okay, that's all it's doing. So this was the red one. And what color did I use? I forgot what color I used. Blue. And this is your blue graph. Okay, so that's all that number is going to do. Okay, it did not change my asymptotes. It does not change. Okay, because again, I did not add a number on the denominator and I did not add a number to the side. So now let me give you an example of those. So if I have y equals, I'm just going to put the 1 on top, and I have, let's not make that long. If I have x minus 1 plus 1, okay? So let's look at what that does to my graph. So normally my horizontal or my vertical asymptote is at 0. Well, now I'm going to say I have x minus 1. That cannot equal 0. So x equals 1 would make it equal 0. So I am at 1. Okay? But if you think of it again, like our parabola moves, x minus h, okay? That h value is a 1. It's just moved it over 1. My horizontal asymptote, again, this is your plus k, it moved it up 1. Does that make sense, what we're doing? I'm looking at it in terms of translations. Okay, so this minus 1 moves it up, or sorry, moved it right, and the plus 1 moved it up. So my horizontal asymptote is no longer at y equals 0, but it is at y equals 1, because I just moved my graph up. Okay, so again, remembering the basic function, your asymptotes are at 0 for the vertical and 0 for the horizontal. I moved my x, in other words, I moved it left or right, which is moving your vertical asymptote. It's just shifting it. I moved it over 1, and I moved my horizontal up 1. So now, when I go to graph it, I did not change the points so that, I did change the points. So now when let me just put you a number in. I'm going to put in f of 1. Not 1, sorry, because that's my asymptote. Let's pick 2. So I'm going to pick this point right here. So f of 2. And so I'm just going to put that in. 1 over 2 minus 1 plus 1. So that would be 1 over 1 plus 1. So that would be 1 plus 1 is 2. So at 2, I'm at 2. Okay? Now, again, what I was going to say earlier, but I wanted to show you that. Since I did not change this value, all I did was picked up my graph and I moved it. Then this is still just like the graph we had here. Okay? All I've done is I've just shifted the whole graph. So that 1, 1 point is still there. Okay? And so that's going to come in and then set inside here. And that means this one is going to, now this kind of becomes my new origin. Think of that as my new origin. Okay? New origin. Okay? And so now my -1, -1 from there would be here. And that's going to set right inside there. Okay? And that's all you need to do. Okay? Let us try one more where I can ask you questions. So follow along and answer the questions. Oh, what happened there? So here's my 1 over x minus 2, and I want to do minus 3. Okay? So in terms of my vertical asymptote, again, it's basic as a 0, but where did I move? How many did I move on my vertical line? Okay, so my vertical line is normally at 0. How many did I shift it? Okay, and the answer is I shifted it to the right. Okay, again, because this is x minus h, that's my formula. So you see that that 2 is my shift. So this is now x equals 2. Okay, next question. How much did I shift my horizontal asymptote? How much did I shift my horizontal asymptote? And the answer is I moved it down 3. So instead of being at 0, it is now at a negative 3. Okay. So again, think of this as my new axis, my new x and y axis. Okay. It's not really, we didn't really shift the axis, but we shifted the whole graph. But it's easier to think, okay, I just moved it. Okay. Again, looking at that equation, guys, I did not change this number, so I didn't move this out any. Okay. All I've done is took the graph and I just shifted it over. But I didn't do anything else. So in terms of my graph, that 1, 1 point and negative 1, negative 1 is still right where I had it. And then I'm going to come in and hit that point. Okay? Now, I don't ask you to do a lot of points, but I do expect that you should be able to hit that main point right there. Okay? And that's all you need to do. One more of these. So y equals, I'm going to put 3 over x plus 2 plus 1. So take a look at that. So my first question is vertical asymptote. Okay. On my x, how much did I move my x value and in which direction? If you cannot answer that question, then the question is, remember, vertical asymptote is what is excluded. My excluded values. So it is that x cannot be a negative 2. So that is what my asymptote is. Okay? So I'm going to draw at a negative 2 that asymptote. Next one. Question is, what would be my horizontal asymptote? How much did I move it up or down, my graph? And which number do I need to look at in order to determine that? And that would be this value right here. So it says that it's added 1, so it moved it up 1. So my asymptote is now at 1. Okay, now what's the graph going to look like? Okay, we know it's not squared, so it's going to set in this quadrant and this quadrant. Is it going to hit 1, 1? The answer is no, it's not. The next question is, what does the 3 do to your graph? Okay, and it does move it again, out. Moves it away from that origin piece. Okay? Now, how much does it move it? The easiest thing to do, guys, is to come in with a little quick T-table. And I'm going to put in the number that is just right to the right of this point here. So in this case, a -1. I'm just going to put a -1 in. So that would be 3 over a -1 plus 2 plus 1. So that would be 3 over 1, which is 3, plus 1, so that's 4. So I'm at a -1, 4. So plot that point. So I'm at a -1, 1, 2, 3, 4. Oops, I counted up too much. 1, 2, 3. There we go. 4. Okay, so I'm at 1, 4. Now, guys, if you'll remember back to what I told you earlier, remember normally it hits at 1, 1. If there's a 2 on top, it's going to hit at 1, 2. If there's a 3 on top, it's going to hit at 1, 3 from that new origin. Okay? Again, I could put in more numbers. I could put in 0. Okay? If I wanted to, so 3 over 0 plus 2 plus 1 would be 3/2 plus 1, which would be 2.5. So at 0, I'm at 2.5. Okay? But that gives you enough points that you see what's happening here. And you can come in here and do this. Now it's going to be just the reflection over on the other side. So if I'm up 3 here, I'm down 3 here, and then I was up 2.5, so I'm down 2.5. And there becomes your, that one looks really bad. I can't turn my arm that way. There we go, a little bit better. Okay, it's going to come down in through here and hit. Okay? Okay, so that is your graphs in which you have a number on the top and just a variable x on the bottom. Okay, so be able to recognize